Okay, this is an example to go along with section 6.2 in your book, solving systems of linear equations using substitution. So first of all, our original problem here is in the black ink, 3x plus y equals negative 13, and negative 2x plus 5y equals negative 54. So for using substitution, our first step is to solve for one of the variables in one of the equations. Here, our first x has a 3, our first y has a 1, our second x has a negative 2, our second y has a 5. These are all the coefficients. Obviously, I want to solve for the one that has a coefficient of 1 already, which is the y in the first equation. So if you follow the blue arrow there down to the third line, we solved 3x plus y equals negative 13. We solved it for y by subtracting 3x from both sides. So we have y equals negative 3x plus negative 13. So if y equals negative 3x plus negative 13 in the first equation, in order to solve my system, I want y to equal negative 3x plus negative 13 in the second equation. So I substitute that value for y for the y in the second equation. I rewrite it there. We're on the fourth line now in the black ink. We have negative 2x plus 5 times, instead of y, we're going to substitute negative 3x plus negative 13 equals negative 54. Then this is a multi-step equation. Go ahead and solve for x. You can see the steps I took there. And we get x equals negative 11/17. Sometimes our answer is a fraction. We have the opportunity to go back and check our work when we're all done with this. And so right now we're going to go ahead and plug our x into either one of the original equations. If you notice the word or there on the right in the blue ink, I can plug that x equals negative 11/17 in for x in the first equation or the second equation. As long as I go all the way back to the start of the problem and use one of the original equations, it doesn't matter which one I use. I chose to use the first one. I plugged it in, and by solving for y, I got negative 188/17. Now, if I wanted to check my work, I would plug negative 11/17 in for x in the first one, negative 188/17 in for y in the first one, and make sure I get a true statement, negative 13 equals negative 13. I would do the same for the second. I'd plug in x next to that negative 2. I'd plug in y next to that 5, and I would make sure I got a true statement of negative 54 equals negative 54. And I would. This is the correct solution for this system using substitution.